I'm going to talk about optimizing React Native performance, strategies for incremental improvements. All right, who I am. My name is Summer Knight. I've been a professional software engineer since 2008. I've been focused primarily on React Native since 2015. I've been with Rocket Money since 2023, working as a senior software engineer. I'm currently on the Rocket Money performance and developer experience team. And I was able to convince the entire team to come out today. Can I get you to clap? Woo! Thank you. It's the first time I've seen some of them in person because we're a remote company. All right. So who this talk is for? If you're working on an existing React Native app, you want your app to feel faster, you don't want to break your existing user experience, and you don't want to rewrite your app. And the converse to this is that this will not be useful for people who are starting a new React Native project, since you'll hopefully be using best practices today as well. It also won't be useful if you believe that your app's performance is acceptable. If it's good enough as is, then things are good enough. You don't need to take a bunch of steps. Also, if you are willing to severely break the existing user experience and do something like a big rewrite that can take weeks or months or years potentially, then if that works for you, that's great. It does not work in every situation because we need to maintain our existing user experience because all our fancy A/B tests have told us that our current track is profitable and we need to keep doing that. Why performance matters. I'm going to cover 4 points: perceived performance, user experience, the effect on sales, and sense of security. And for details, oh, hang on. My notes are on my phone instead of on the computer, so it's slightly awkward for me. First impressions. So the initial loading time and smoothness of the first interactions can significantly impact a user's willingness to continue to use the app. For the user perception, users will often judge the quality of an app by its responsiveness and speed. Fast load times and smooth interactions create a positive perception. Smooth animations can significantly help a user feel like the app is still doing something, even if we do have to wait on something that could take several seconds. User experience. For the satisfaction, a performant app leads to higher user satisfaction as it feels more reliable and enjoyable to use. Retention, which is extremely important for us at Rocket Money, because we are a subscription model. You pay once, monthly or yearly, and we want to retain you as a user. So users are more likely to continue to use an app that performs well, leading to a higher retention rate. Engagement. Faster apps encourage users to engage more frequently and for longer periods. This might be much more important to your app than it is to ours, per se. Some of our users only use the app once a week. I know that one user opens the app, I think every 10 minutes, something like that. Far too often, but that user has great engagement. So the effect on sales, and I know this was covered in the last talk a little bit. The conversion rates, performance improvements can directly affect conversion rates, as faster apps make the purchasing process smoother and far less frustrating. The revenue, the enhanced performance can lead to increased user retention and engagement, talked about in the last slide, directly impacting the sales and revenue. And competitive advantage. A faster, more responsive app can be a key differentiator in a crowded market, attracting and retaining customers. All right, the sense of security. This is kind of a wishy-washy, interesting thing, but if your app is more performant, users will feel like it is more secure. It's a fun psychological phenomenon. They will feel like they can trust the app more. That like, oh, well, it didn't glitch out in this one part, so clearly I can trust them with my banking details. For the data integrity, a responsive app can give the users confidence that their data is being handled securely and efficiently, reducing concerns about data loss or errors. If you're throwing errors at your users, expect them to not trust your app. And consistency. If you have consistent performance, that reassures users that the app is stable and that the user experience will be smooth and trouble-free and affects all the points it covered before. So tackling bottlenecks. So we're all speaking the same language. I'm talking about bottlenecks that are specific to a computing device, specifically a smartphone and the app that is running on your smartphone. I'm less concerned with network, although I'm going to talk about that later. Often we'll be talking about network bottlenecks, but this is specifically your React Native app running on your phone. All right, module loading. Hermes and Metro and Babel and the entire React Native ecosystem probably doesn't work precisely the way that you think it does. Here we have two examples, ECMAScript module on the left, CommonJS module on the right. For all practical purposes, these can be seen as the exact same. In fact, the left-hand side will pretty much compile into the right-hand side. That'll then be put into a big bundle and then compiled yet again for the Hermes compiler, put into bytecode. But it roughly, if we can think about things in terms of CommonJS, that is more accurate to how React Native behaves, even though ECMAScript modules are the future of ECMAScript JavaScript. They've been the future since 2016. Here's an example of React Native's index.js, and this is just a small snippet of it, but we can see this is not an ECMAScript module, this is CommonJS because we're doing module.exports and setting that to this object that only has getters on it. So that when, let's say, image is requested from the React Native module, only libraries image will be loaded, and only at that time in that lazy evaluation. And in that example, pressable would never need to be loaded. But this is also only 3 examples out of, I think, 50 or more within just the React Native root. Here's an example of visualization of roughly how the modules get loaded into your React Native app after the iOS and Android specific code is run. So I'm talking about it in terms of JavaScript code that we have control over and some which we don't. React Native initialized core is the first thing that's loaded, no matter what, before any of your handwritten JavaScript. And we also have our index.js file. These are the 2 things that get loaded back to back. But first off, we need to load the initialized core, and that will load a series of other setup files. All in all, those 4 blocks are very fast in the sense of it takes about 78 milliseconds on average, even in dev mode. I've never seen it take longer than 100 milliseconds, even on older devices. Once we finally try to load my app, what we're going to do is try and register the we're going to try and import app and then register that by calling React Native.register component. And let's say that app TSX also has a Lodash dependency. Oh, but then we get into this conundrum that we needed to load the app component, and that is importing several other screens, navigators, it's configuring Redux, it is doing a lot. We're actually also loading multiple versions of Lodash because it's easy to do that. Lodash is easy to pick on here because it's so widely used and used in different ways. You can use Lodash-ES, you can use regular Lodash, you can use Lodash.merge and all those other ones. All those like Lodash.merge projects and things like that have a significant chunk of Lodash as part of it. So you end up naturally with code duplication. There are mitigating ways around this, specifically for the Lodash case, but there's ways to mitigate this for most circumstances. I'm going to get into solutions. There we go, solutions. Isolate side effects, import modules lazily, avoid re-exports, and avoid unneeded dependencies. Also, to reset context, this is specifically for React Native and not for React Native targeting DOM or even potentially targeting Windows or another non-iOS, non-Android target. So, isolating side effects. Here's roughly what we ended up with, where every single possible side effect of, I wanted an empty file for the baseline, just to know that like, oh, that took 0.1 milliseconds or however long. And then loading Sentry as the closest to the first thing as possible, because if an error occurs at any point in the entire app's lifecycle after that, I want to know about it. And then configuring Logbox, that only matters for development. So in production, it ends up being an empty module. Same thing for why did you render? That's another development tool. Loading React Navigation, that just does the import, but because React Navigation is so heavy, it became valuable to separate it out so that we would know that, oh, this is taking 250 some odd milliseconds just to load this library without even mounting any components whatsoever. We also initialize Singular. We load the internationalization polyfill, which is an empty module in Android, but it needs to do something in iOS, at least for us. Datadog, because we want to send metrics to our big data stream and actually get the results of how long users are taking to load all these things into Datadog. And then that Redux store, that's just the synchronous configuration of our Redux store. That does not include any of the asynchronous loading after the fact to like repropagate the session and get the user back to the state where they were. So that asynchronous loading occurs after all of these synchronous side effects. And then finally, what we initially were just using our index.js file for, we register the app. And that's our last step. Importing modules lazily. Here's an example using React Navigator. On the left-hand side, we are loading things eagerly. On the right-hand side, we're loading things lazily. You can see because it's doing the direct imports on the left-hand side. So before my navigator, before any of that code is even exported, it needs to load all of the dependencies of screen 1, 2, and 3 any sub-dependencies they have. It can be a surprisingly large amount. And that is regardless of whether we're viewing any of those particular screens. If we look at the right-hand side instead, if we use this React.lazy syntax and the asynchronous dynamic import, within React Native, although the dynamic import is asynchronous, because all the code is available on device, that will resolve synchronously, or it'll resolve on the next tick, but for all practical purposes, it'll be synchronous, and you don't need to expect to have a loading spinner for that particular case. Though loading spinners are going to be great when we're dealing with network requests and things along those lines. A useful guideline is that at these navigation points where we're rendering these screens, that is a good place to do these lazy module imports. Because if we had all of our code always importing dynamically, that would be oh so burdensome. And writing any particular screen should be a straightforward thing to do. So you can do this without rewriting any of your existing screens, just the navigator code. Avoid re-exports. Here's a small snippet from a hooks/index.ts file where I show you 4 out of the 50 some odd items that are in here. The problem with this code in React Native specifically is that useABTest is imported, and then that useABTest binding is re-exported in this index. And so if I want to import useInterval, for example, I will need to load all the code for useABTest and useCodePushPackage and useInterval and useSaveHeader and all of those dependencies and everything. All those benefits that we might have gotten from lazily loading in the navigation system, those would go away if we had several of these barrel files. All hope is not lost, though. Here is a hacky solution that I don't recommend you implement. But this is oh so similar to what we saw with the React Native index.js. But if I were to import useABTest from hooks, it only needs to load that one file now. Of course, I like using TypeScript, as I hope many of you do, and getting this to be typed correctly is also burdensome, at least without relying to hacks around the any keyword. I would love to see a Babel plugin that just does this automatically, which probably means that I'm going to be writing a Babel plugin in the next week. And avoid unneeded dependencies. This is probably the hardest thing to do. One example is multiple versions of the same library. I have seen in multiple situations at Rocket Money before things got fixed, and in other companies as well. I've seen 5 separate versions of the full Lodash being loaded, as well as many other different packages. I just like to pick on Lodash. Libraries that serve the same purpose. You might have a wonderfully constructed React Native app that's using Redux as its centralized state store, and a few years later, somebody thinks like, oh, well, this Redux store is really cumbersome to work with. You know, I'm gonna use my own solution. I'm gonna use XState for this feature. And it works well. It works great even. And then somebody has the same idea the next year, and on their team, they make their state work with Jotai. and maybe the next year it's Zustand, and you end up with 4 different state machines in the same app without even considering use state and use reducer. Libraries where only a tiny fraction of functionality is used. This can be kind of hard to determine at times. I would argue that Moment is a good example of this, where you might just need to know the day of the week of some date, but you're loading in a lot of code in order to figure that out. Datefins is an amazing example of a library that is counter to this, where you can import just one specific function, and it'll only load that code that you need. And libraries that were valuable 5 years ago. I work with brilliant people, and time makes fools of us all. Some of the things I did 5 years ago are just awful in hindsight. And there's still things to claw back from that. Whether you caused this yourself or you're dealing with somebody else's messes, probably somebody else's messes that have been gone from the company for years now. If you can somehow reduce the number of dependencies, you're gonna have a better time. All right, network data. I told you I'd talk about it eventually. This is really going to be on a case-by-case basis. Based on what your app is doing and who your app is targeting, the answers to these questions are going to be different. So how fast is the user's network? If you are making an app that is targeting tech bros who live in major American cities, then that is significantly different than if you are targeting people in rural areas or international areas. How reliable is the user's connection? That's also affected. If a user goes through a bridge and comes out the other side and your app just gives them a useless error that they can't do anything about, your app is broken. It is not the user's fault that they went through a bridge. You need to handle those situations. How much data is reasonable to send to the user? It can be really easy to get in the habit of sending multiple megabytes of JSON to the user in the first few seconds of app load. And it's really hard to claw that back after the fact. So be aware of what your data flows look like and how much data the user actually needs. And can we start loading data earlier? During that app initialization part, as soon as we know what the user's auth credentials are to be able to make a request, we could immediately send out a request that pulls back all the experimentation cohorts that user's in, all the feature flags, all of that can start loading up front, which won't affect the execution of your JavaScript code, but the data will just be available for you when you need it. Reduce unnecessary renders. Unnecessary renders are often not a problem, except in all cases where they are. Suggestion here, use ESLint plugin React hooks. It works well. It'll help for some things. I am really excited, though, for the upcoming ESLint plugin React compiler. The React compiler is not ready for prod yet, and this ESLint plugin is still on version 0.0.0, but this will provide a lot of functionality to ensure that your app is ready to adopt the compiler and should work with existing code. I'm hopeful about that soon. I hope soon doesn't mean 2 years from now. All right, and Why Did You Render is also a great tool for reducing unnecessary renders. Ooh, animation. I hope you saw that cool animation. Use animations. They're wonderful. If you know that you're loading something and that's gonna take 500 milliseconds or even a full second or even longer, if you can provide an animation to distract the user appropriately, then you won't even notice that the bar chart is meaningless and has nothing on the x-axis. And some systemic changes that I strongly recommend to people. Upgrade React Native to as recent a version as you can and try to adopt the new architecture. There are wondrous efficiencies that are just waiting for us to grab. All right, thank you so much. My name is Summer Knight. And, oh.